Hello all. Today I want to share with you a recent pickup that I have. This is a Color Computer 2 and I've been hunting for one of these. You might remember in a previous video that I picked up a Color Computer 1, but I wanted to leave it kind of in its unmodified form. This one I plan to do some things too with memory, adding extended color basic and other things. But first I'm going to have to do a little work on this machine. The previous owner told me that this machine for the most part works, but that it has keyboard issues. And that's what I'm going to check out now to try to figure out, is it the keyboard? Is it a chip? Hopefully it's just a keyboard membrane. That should be a fairly easy fix. So let's go ahead and take a look at this machine and see what the keyboard issues are. All right, so we can tell from the screen so far that this is a basic model. It doesn't have extended color basic, and I'm pretty sure that it is a 16K model. We can see that there from the memory count. So very basic machine, and does have a keyboard issue, though maybe you've already noticed that when I did the print mem that the spacebar didn't work. And so the first thing I want to do is just kind of do a quick map out and see what keys are working and what keys aren't. All right, we can see that quite a few keys are not functioning. And if I look at what keys are not working, we have our W, our O, our G, as we discovered early on, the space key. It looks like the 7 key does not work, nor does the question mark backslash or the left shift. So interestingly, I think we can find the source of the problem. If we go ahead and look at the keyboard matrix for the CoCo 2, one of the things that I notice is all of those keys share one common line, and that goes to the keyboard connector on pin 16. So I think where we'll begin is to disassemble this CoCo and go ahead and try to do some typing right from that keyboard connector so that we can eliminate a chip as the problem on this CoCo 2. All right, first things first, I'm going to go ahead and pull the keyboard carefully. These ribbons look pretty fragile. And I'm just going to set this over here. Now let's go ahead and power this back up. All right, I'm just going to use a little jumper lead and kind of probe around on this keyboard connector and see if we can actually get that missing row of keys to work. The reason I would do this is just to eliminate the possibility that it's a chip that's bad. So we are looking at connectors, we're looking at 16, and let's take one of the keys that didn't work, the W. And if we do 4 and 16, we should type a W. So let me power up. And we will go from pin 4 to pin 16. And there, that's good news because it looks like it's actually in the keyboard and it's not a chip. Just for one more, we'll check out our space bar, which is pin 16. And pin 5, at least if I've counted right. There we go. We have our space. So that's just a quick check that you can do to make sure that indeed it is the keyboard and not a chip. So With that, I need to start taking a look at this keyboard and see what we can figure out about that. Now, in the worst case scenario, this is a really quick fix. I could simply just replace the keyboard membrane, and that would take care of my issue. But before that I do that, I actually want to see if I can rescue this keyboard and figure out what's wrong with the membrane that's there. And one of the things that I was thinking, and it might be a little foolhardy, but I'm going to try anyway, is they make these circuit pens. And if this is really indeed just one of the traces on the keyboard membrane, I'm going to give this a shot and see if we can get this working. Okay, to start, I just want to see what the resistance value looks like for a key that's working on this cable or this membrane. So I'm going to try the V key. That was one of our working keys. And it looks like we get around 100 ohms if I hold still. And let's take, for example, another one. Let's do the F key, which is pin 1, and again we go over to line 16, and just another quick check. And that one's reading a bit higher, so I'm not sure what the actual value of these should be. Yeah, this one's about 492 ohms. So 100 ohms, 492 ohms. Now let's check one of our keys that doesn't work. We'll look at the W key. Okay, now we're getting a really high reading, like 8.5K. Let's pick another one of our non-working keys. Let's look at the space bar. So that's pin 5 and pin 16. Okay, again, over 8K. So the one thing that all those keys have in common is they have this line 16. So I'm going to guess that's where the problem's at. And somewhere I'm thinking that this kind of carbon coating or whatever this is damaged, or you know, perhaps it's had something that hasn't broken the continuity entirely, but maybe moisture or something that's degraded that membrane. So the next thing to do is to go ahead and pull apart this keyboard, pull the membrane out, and then I'm going to trace around the membrane really quick, see if I can find anything. If it looks like it's going to be too big of a problem, then we're just going to replace the membrane and move on. I'm going to put just a couple of screws back in just to make sure that we don't lose keys and springs all over the room. So this is proof that I can learn from past mistakes. Okay, in theory what I'm looking for is I'm going to be tracing that line 16 around the board, and somewhere, and I suspect it's going to be somewhere on this part of the membrane, we're going to find those high resistance readings. So first thing, I'm going to just check this first little stretch here, and we do have a pretty ugly crease in the membrane right here towards the start. But we're getting a fairly reasonable resistance level, only 11 ohms. And then I want to get on the other side of this. Okay, 80 ohms. we'll just jump over. Okay, only 11 ohms there. And over to the keypads here. 32. Okay, those are still not too disturbing. There we go. Okay. So it's in this outside loop here somewhere. We are really bumping up the resistance. Okay, it actually looks like our problem is in a narrow stretch right here, and there's no break at all in the contact here. But I suspect that maybe I'm wondering if there isn't something liquid damage or something. I'm not seeing it, but for some reason we're getting really high resistance value there. And it's only between here and here. So I think that's the stretch that we'd be looking to try to repair. And what I'm wondering is if I could try that pen. So we know that we have good continuity back here. So I am going to try to coat this trace from where it's good to our problem area. You know, and there is a discoloration in that area, even the area that we haven't done yet. And it looks like the discoloration goes from, here to here. So probably just around this corner. So if we can repair that, maybe that's where I should have started, was looking for discolorations. So one thing I figured out is you have to prime these pens. There is a little bit of a plunger in the back, and you can press that plunger and things work quite a bit better, but you have to take the pen little cap off the back. So now we have a pretty good trace there. I need to give this a bit of time to dry, and we'll see where we are from there. Okay, it's dried pretty well. Let's take another look. Okay, 20 ohms. I think that looks better. Go back to the top. Yes, now that looks pretty much in line with what we see on the other traces on this membrane. So I think we're going to put this back together and see what happens. And just before I put this completely back together, I wanted to give you one more look. Just kind of right here. I don't know if it shows up on the camera very well, but there is a discoloration right around here. And my suspicion is there may have been moisture damage. I can't think of what else would do that, but I think that's a pretty good possibility. All right, let's power up. Now the moment of truth, those bad keys. Especially, we can start with the W and the space bar. Ah, look at that. And the O and the G. Great. Okay, so we fixed our CoCo 2's keyboard. The circuit pin actually does work. At first, I didn't think this was a very good device, but then I noticed there was a little plunger in there, so I pulled off the cap, pushed down to give that a little bit of pressure, and then it got a really good flow out of the pin. Corrected that damaged area on the keyboard membrane, and everything's working now just fine. So that is a method for fixing a CoCo keyboard, at least on these CoCo 2s. And now I can save this membrane for another project. Maybe I'll get another CoCo 2 that doesn't have a salvageable keyboard membrane. The other thing I've been told is that these are actually a bit nicer than the original, so maybe someday I'll put that in. But for right now, I think I'm just going to put this back together with its original parts. And then after that, in another video, I'm going to look at expanding the memory, adding extended color basic, and starting to kind of upgrade this machine. One of the other things I'll want to look at is doing something other than the RF out, but that won't be for right away. So I'm just going to go ahead and put this back together. Now that the CoCo 2 is back together, I want to test the keyboard again really quickly just to make sure everything's in order. And there we go. I do have to say that this keyboard does not have a very good feel to it. The keys are well, they work. I can say that. And I'm glad that they do. But certainly I would understand why somebody would have some criticism of the feel of this keyboard. Well, there's our test. Well, that's pretty much all I have for today. And thanks again for watching.